FireBytes. Thank you for joining us in this December day. It's a little bit blustery in the Northwest, and I'm hoping for some snow this year, so let's all do our snow dance. But until then, let's go ahead and cover some of the more exciting features of a firewall, and that's really around this idea of network address translation. I remember back in the day, original days of the internet, it seems like every computer on the network had a public IP address, and then we started looking at all of the IP addresses as a whole, kind of reevaluating, and for a number of reasons, looked at network address translation. Originally, it was also port address translation. And really, it was around some of the ideas of we're going to run out of IP addresses. Not everything can have a public IP, as well as this network obscurity or hiding what you have on your local area network resources, and then having your firewall do that. So again, my apologies if this might be a little basic for some of you. Hopefully throughout the course of this FireBytes session, there's going to be something that's going to pique your interest, something that a nice little tip or trick that you'll be able to glean from this and be able to apply as a network engineer in your role. So again, just a brief recap of myself. I'm the Northwest sales engineer. I was in a public school district as a network engineer and a director of technology for about 14 years in Oregon, through which I was also I've covered everything from PIX firewalls to Sonic walls to actually I was a WatchGuard customer in a school district. So as we go over the session today, again, we're going to keep it short and sweet. Your time's valuable. We like to just have everything within around 30 minutes for you. Again, we'll go ahead and record this and post it to our YouTube channel, again, so that you have access to it. But today we're going to cover what is a NAT, network address translation, different types of NAT as applies to WatchGuard, the precedence of those NAT roles, and then how to host a server. So again, while this may seem basic to many of you, I do have a number of questions still, both from new prospective customers, as well as customers that may be using WatchGuard for some time that say, I have a new project coming, we need to host a server. How can I host that server on my local area network, as well as publish resources of that to the outside world? So we'll cover that, both with a private IP as well as a public IP type topology. So what is NAT? And again, I just had a conversation the other day, and I realized that sometimes as a network engineer or someone that is ultimately familiar with some of these terminology terms such as NAT, that we sometimes don't break it down enough for everyone to understand. So what is a NAT? A NAT is a network address translation. It really is a term used to describe any of the several forms of IP address and port translation. At its most basic level, NAT changes the IP address of a packet from one value to another. Now again, if you may recall from other FireBytes, I like to spend less time in the slide, so bear with me on this, and then we'll get into a live scenario as well. The primary purpose of a NAT are to increase the number of computers that can operate off of a single publicly routable IP address, and to hide the private IP addresses of hosts on your local area network. When you use a NAT, the source IP address is changed on all the packets you send. So pretty clear, as I mentioned, the two reasons: security, as well as increasing the number of computers on your LAN, so that you don't necessarily have to have a public IP for all of those. Now, if you did still, let's say you did have a large a subnet of public IPs, you could create a one-to-one NAT, which we will cover as well, if you wanted all those computers to be just routed with their public IPs. So as we look at a standard network topology, again, hopefully this resonates with a number of you, a number of sites that I visited. This illustration would depict pretty much what their network is. Maybe a little more complex on some of the trusted networks and optional networks. But as we look at this, we have the internet coming in. And in this particular case, we have a primary IP address. We are using /24 for this. We actually have some secondary IPs as well. And most of the time, if you get any sort of business class network, or you have, with a business class, you're typically going to get about 5 IP addresses, maybe more, maybe less, depending on your institution. Now, in some cases, you have a trusted network, and again, the only difference with a trusted and optional network on a WatchGuard is we're creating different aliases to be able to easily distinguish what is on my trusted network versus optional. Now, as you can see here, many use the optional for a DMZ. Maybe you have some servers on there. Maybe it's a guest Wi-Fi and a car dealership that they want to have separate from the PCI traffic. So you can create any number of aliases on WatchGuard. The other thing that people don't necessarily realize is that as we look at all those ports on front, many of you, again, my apologies if you're well aware of this, but with WatchGuard, we have the ability to create any one of those ports. Can be an external, a trusted, optional. We can go ahead and reassign those ports. A very flexible configuration that WatchGuard provides you, which is great as a network engineer, because your needs today might be completely different than the needs you have from 6 months or a year from now. So with this, we can easily set up 2 external ports. We've talked in previous FireBytes about having that multi-WAN failover, or excuse me, a WAN failover, so that maybe your Comcast connection is in one and it goes out one day. We can actually spin up your AT&T 4G cell modem and have all traffic go out that way, and have that flexibility. So in this case, we look at the different types of NAT. We have a dynamic NAT, and that's handling all translation for traffic as it leaves the Firebox interface. So let's say we're on this computer and we have traffic going outbound. The dynamic NAT is going to handle that traffic. Now, depending on your scenario, when I was in a school district, I actually I thought it was quite convenient to have all of my students, or you could even break it down to a group of students, like a grade of students or whatnot, but a group of students would leave my interface with a particular IP address. And it was actually quite handy. One day, someone knocked on the door, or actually they called me up, and it was the FBI, and they had some questions about some of the user activity. And just from that IP address, I was able to identify that it was within my student group. Again, no surprise there. If any one of you work with schools, you know that students create interesting content or serve interesting websites. The static NAT is going to handle everything that enters an external interface. So whether it's that you're publishing a mail server that we have here, or maybe it's that you're publishing a website, any traffic that's going to come from your external to internal is going to be handled by a static NAT entry. Now, if neither of those fit the bill, we want to have a more flexible scenario. Maybe you have a call manager that you want to have a VoIP server that you want to publish out to the internet because you have remote workers all over the world and you need more of a one-to-one app. Again, we can create that rule as well, so that all of those, all traffic from one IP inbound to another, or is resolved to a private IP, which we'll talk a little bit more as well. So as we talk about different types of NAT, again, we had covered this briefly on our previous slide, but a dynamic NAT is also known as IP masquerading. Again, we're taking those internal resources, hiding those under one public IP address, and the firewall's handling all of that. So the Firebox can apply its public IP address to outgoing packets for all connections or for specified services. Now, as you talk about multi-WAN and some of the other features of maybe a round robin, now we come into a sticky connection conversation, which we can absolutely specify as well. But that, again, as we talk about server load balancing, that's a great area where we would need a sticky, and we'll talk about how that applies. This hides the real IP address of the computer that's the source of the packet from the external network. Dynamic NAT is generally used to hide IP addresses of internal hosts when they get to public services. And then a static NAT is known as port forwarding. You can configure static NAT in a static NAT or SNAT action, and then use that action when you configure policies. You can do a static NAT port to host NAT. You also have the ability to change a port behind the firewall to actually do a port forwarding, which we'll talk about some of the use cases for that as well. And then a one-to-one, as I mentioned, it creates that mapping between a public IP address on one network to a private IP address on another network. This type of NAT is often used to give external computers access to your public internal servers. Again, whether it's that you're a VoIP server or maybe a video server that has more dynamic ports. If it's something like port 80 for a web server, that's pretty easy to create a policy for. However, there are some applications, some servers out there that have more of a dynamic ports. They're hopping back and forth between maybe 1780 and different ranges, and then you can create a one-to-one NAT for those scenarios. So a dynamic NAT. Now, as a little tip here, the dynamic NAT, the default configuration of WatchGuard includes the following entries. So 192.168.172.16 and a 10 address. Now, just as a heads up, that if you want in your network to have any sort of other a special NAT rule or a special network topology or configuration within your network, you might actually have to go and configure, add in some more entries. Also know that I had one customer that was actually using one, created a rule or a private address scheme that actually conflicted with a fire cluster. So just make sure that you take all of those needs into consideration. Are you going to be running an HA scenario? What other IP addresses are going to be on your network? And you can specify that. You can add or remove those as needed. You can also apply dynamic NAT policies on a network level or through the policies. So when I talk about a network level, I'll show that to you. And again, for the sake of the majority of you out there, you're using the policy manager, the Windows application. So I'll show that to you, as well as I'll show you a bit on how to make these configuration changes on the web UI as well. So a dynamic NAT source IP address can be configured by a network level or through policies. Allows you to set the source IP address for outbound traffic. And surprisingly enough, something like this source IP address can solve a variety of technical use case scenarios that we might actually have out there. For instance, I had a customer call up, and they had a Dimension server that had to go over a branch office VPN link to a Dimension server. So when they went in and they published that IP that did the mapping for that, hopped the link over the branch office VPN to Dimension server, they could actually set that source IP address so that that traffic also had the ability to exit or to return back to that source as well. So again, as you go into those more unique situations, again, that source IP address, the ability to be able to set that is a great tool. Now we also have a static NAT entry. A static or a SNAT is a NAT mapping, network address translation mapping, which replaces the original destination IP address and optionally port with a new destination. So again, as we talk about, you know, again, WatchGuard as in comparison to some of our competitors out there, where you need to create, go through a wizard to create a static NAT rule that takes you through maybe 20 different screens. Okay, so maybe that's a slight exaggeration, but you get the point, especially if you've tried to do it on some of our competitors. And then you hope that ultimately that everything went through, all the wizards created properly, and you have 20,000 different objects to manage for one static NAT rule. With WatchGuard, we just can create a static NAT entry within a matter of about 3 clicks, be able to see all those policies in one location, and be able to manage or create policies for that. So we'll cover how that works as well. You can also set an internal port to a different port. as a port forwarding. Now that allows you to publish some creative solutions as I have there. Now, while I don't, from a security standpoint, I don't recommend at all publishing any RDP resources. What you can actually do is hide some of your 3389 resources and publish them out as a 5,000. Again, not a security measure at all, but it allows you to have some more creative solutions. So again, while I don't recommend doing this, that is one use case scenario that you could use for port forwarding. Now, OnetoOne NAT, as I have briefly mentioned, allows you to map that outside IP to the inside IP, and it gives you the flexibility of saying all ports within there. And a lot of us really don't have the flexibility of giving up one IP address, especially when you know, although a lot of a lot of our resources are getting moved to the cloud, so that's freeing up some IP addresses or some servers locally. But maybe we don't have that flexibility, or maybe we want to do that one-to-one mapping. Again, we'll cover how to do that. But as we look here, the user is going to .11, and then we're going to map that to net meeting. And again, that's just as a sample with a sample application with dynamic ports that allows us to have that full mapping in there. Another use case scenario is this user is trying to get to .13 as an Intel video phone, and that maps to .13 on the optional network, and we'll cover how to do that as well. So the precedence of NAT, again, just an important tip to cover. One-to-one NATs always have a higher precedence than dynamic NATs. And then policy-based dynamic NATs have a higher precedence than a network dynamic NAT. So just know that as you're going through, you're looking at your network topology, creating your network diagram, your one-to-one NATs are always going to have the highest precedence on there. So the other thing I wanted to cover real quick is how to use public IP addresses behind the firebox. So while this isn't necessarily a NAT conversation, a lot of times people say, well, can we publish a web server with that public IP? And the answer is absolutely. What we can do is create an optional network, optional DMZ that public IP is mapping directly through, and we'll show you how to do that in the configuration. So with that, fortunately, we can get to the hands-on part. Thank you for bearing with me on the slides, but definitely some useful wording in the slides I wanted to bring to your attention. So in this case, we have a configuration, sample configuration here. That the first thing I wanted to bring your attention to is under the network, we have our NAT configuration. Now with this is our dynamic NAT. So maybe I have a need for creating a more interesting scenario, again, not recommended from for a variety of reasons, but maybe I wanted to create another address scheme that I didn't want to have NAT. So in this case, let's say I had an address scheme locally of, let's say 15. We could actually make 15/24 subnet. Again, not recommended. I'm just showing you how we can create that policy. Now we're saying add a dynamic NAT entry, and for this we're going to say any external, and we're going to set the source IP for this. So we could say anything coming from this internal NAT entry. Again, and not the best case of using the 15 dots, but this gives you the idea that you can create a 15 dot internal network and then have that natted out. Now in the event that we wanted to actually use one of these as well, let's remove this 10 address, because I want to point out, as we look at, for instance, at 10.0/8 network, we want to say where you want to NAT anything to the external network. We're going to set a source IP on there. So I could say, let's have all traffic that comes out of my network as a 10.00 from the network it's going to appear to the outside world as 203.0.113.25. Now, many of you do realize, but there's a great tool out there, whatismyip.com, to be able to test out how these policies are affecting what the outside world sees as your IP address. So again, this is a dynamic NAT. So all traffic internal going outbound is going to be looking like a 203 address. Now, if I want, I could actually create a one-to-one NAT. In this case, I have all two hosts on my NAT base of .25 that's being translated to my 2.25 network. So 25 is going to match, and then 26. So anything, again, is just mapping my external networks to my internal networks. Now we can do a single IP. We can also do an IP range that we're doing here, or we can do a full subnet if we have that flexibility with, or that number of IP addresses as well. So quite a bit of flexibility that we can create on the one-to-one mapping. Now we can also talk about, for instance, having a public IP coming in to, so a static NAT entry. So this is what ultimately the static NAT entry is going to look like, a public IP to a private IP. So if we look at, just to back up 1 second, as we look at our network configuration, our interfaces, we can see my external IP has a 113.2 network. So as I look at that static NAT entry, that's going to say, there was also a secondary IP. Sorry about that. Let me show you that. So we have the external .2 address. Under secondary, we can actually add in other IPs. So where myself, I have 5 IP addresses, I have my primary, and then I have my secondary IP addresses specified under my secondary pane. So what that allows me to do is come in and say, you know what, anything coming through, and this is a SMTP proxy. So as many of you are aware, that's going to be over port 25. Anything that comes in on port 25 to this public IP address is going to be mapped to this private IP. Now in this particular SNAT rule, we actually have 2 IP addresses specified there. Let's go ahead and remove it, and let's start from scratch, show you how I did that. So the first step I want to do is just go in and click on Add. I want to click on Add SNAT. Now the difference is if I'm on the web UI, I'll just want to create the SNAT rule first, and then come in and apply it to a policy, which I'll definitely show you a little bit later. So let's say I want to go in and I want to type in FireBytes example. I can also create a description if I wanted to. Again, from here, if you guys haven't checked out a great feature from WatchGuard, in fact, when I invested in WatchGuard, I had a Barracuda load balancer. I didn't realize that WatchGuard had a server load balancer. And then the Barracuda ended up dying out, for better or worse. I came in and did all my load balancing through WatchGuard, and it worked out great this way. And we'll cover how to do that. But our static NAT entry, we have our SNAT members. Now in this particular case, we can say, you know what, anything on a .25 needs to be mapped to, let's just say 192.168.100.25. And that's just as easy as it is. We could also, as I mentioned, that forwarding, for instance, port 5000 to 3389, we could do that setting the internal port to a different port here. In this particular case, we want to go ahead and click OK, click OK, click OK, and that's as easy as it is to create a static NAT rule. Now, again, to recap a number of reasons why we would have a SNAT rule or static NAT is any internal resources, whether it's a VoIP server, web server, database server, what have you, we can create those static NAT rules to be able to apply to them. So this is what we just looked at was all traffic external coming in. We mapped it out. Now the other thing is, as we talk about those mail servers being able to send out mail, and as many of you or network administrators, you're aware of SPF records and building that reputation with your IPs so that other mail servers will accept it. So it really makes a difference what IP that mail is coming out on. So that's actually going to be handled by our dynamic NAT. So if we look at the first example for our first mail server, we're saying anything from our 2.25 mail server, outbound proxy action, again, bringing you that proxy, the security of the proxy, whether it's a virus scanning, DLP recognizing if credit cards are leaked out, or inbound email, running APT blocker on there to see if crypto locker is coming in, and to be able to ultimately stop that. So again, great features of the proxy. Now as we look at this outbound traffic, again, from my internal resource to any external, we go under advanced and we're going to say, you know what, let's go under NAT. We have the ability to use a one-to-one NAT, and we might have that flexibility. However, if IPs are limited, maybe in this case we want to say dynamic NAT, we're going to set the source IP. So any email that comes out from this email server is going to look to the outside world as originating from .25. So pretty self-explanatory. Again, you can use the same setup for any HTTP browsing. As I mentioned, my students went out to the internet. I wanted them to be able to appear as a different source IP, so I had that flexibility here. We also have our second rule. Now, as we look at, for instance, a one-to-one NAT, let's say we wanted to map where I showed you under network NAT, one-to-one NAT here, then you would just need to create a policy to be able to allow those resources in. So in this particular example, this is allowing any external traffic to these internal resources. And because it's a one-to-one NAT, you can see we don't need to have static NAT entries in here. We just use the native IPs, and they'll pass through. Again, we can apply the proxy on there. We also have a public IP server. So that's your public web server that I mentioned I would cover. So if we look at our network configuration, we have our optional network. This is a mail server that's published out to the world as a 198 address. I could actually specify that, specify the optional interface type. And then by using these different interface types, these different aliases, we can create policies to be able to differentiate these and not allow traffic from one interface to bleed over into the other. So again, great for PCI traffic. So again, we have the public IP there, and then we actually have our public IP server. So that's off of here, and anything plugged into that optional network, we're going to be able to publish those resources. And again, be able to apply those same proxy policies to the traffic coming out. And then the other thing I just wanted to mention real quick before time runs out is the idea of a server load balancing. So again, not a great use case scenario, but let's say you had an RDP farm out there that you wanted to round robin connections coming in. What we can actually do is look at how that situation is set up. So in this case, we have our server load balancing NAT. Any traffic coming in on port 3389 on IP.25 is going to round robin between these RDP servers. We can also enable a sticky connection so that if for whatever reason that connection is disconnected, when they come back, they will resume that connection on that same server. So great little feature from WatchGuard. Again, well, it's not that little, a great feature. You can also go to a lease connection on those servers as well. So many of you might have a need for doing some load balancing. The other thing that I wanted to bring up real quick is looking at the web UI where everything is. So this is actually one of our latest T30 boxes. Again, if you haven't checked out the specs for that, this little box is rocks. Just a phenomenal, has a PoE port in there, and allows me to have a total of 5 interfaces, including that PoE port. So this is my T30. So as I mentioned, I want to show you your static NAT rules. So we just go to the firewall, click on static NAT, and under here we would click on add, create that static NAT rule, FireBytes, snap, and then again, just like we saw before, we're going to create, in this case we have only one IP address, create a mapping to .10. We could do port forwarding as needed or set a source IP. Now once we have that, we're going to save that, and then we just go into the firewall policies, and we'll be able to apply that static NAT rule. So we have our firewall policies. I can click on add policy. Let's just say we want to do SMTP. Click on add policy, and now we can specify that static NAT rule. So anything from, in this case, we would want any trusted, or excuse me, any external traffic coming inbound, and we're using that static NAT rule. So again, very similar, very easy to do, just a few differences in how you would create that through the web UI. But with that, we are at the end of our session. Let me go ahead and throw up our email address as well as the YouTube channel. Our next FireBytes is January 7th. Feel free to reach out if you have any questions, any comments, and I have received quite a few from previous sessions. I try to do my best to catch up with all of those. If you haven't heard back from me, feel free to reach out, and again, there's my email address. Oh, excuse me, my email address is not on there. Let me go ahead and throw that on, and 1 second here. My apologies. And then if you have any questions, feel free to reach out to me. If I haven't answered, I will get you the answers, or if you have any topics for future sessions. So with that, wanted to wish you a happy December, happy holidays, and hopefully this session was helpful for you, and feel free to join us. We'd love to have you for future FireBytes sessions. So thank you so much, and we'll see you next time.